Today's webinar is talking about kind of the zoomed out picture of functional safety, that high level view, that overhead view of what functional safety is. And there's often times we get really hung up on what a failure rate is, on how many fits it is, if something has a certificate or the systematic capability, that sometimes we forget why we are really dealing in functional safety and why we're really here. So today I wanted to take a moment, and instead of talking about one of my pet peeves like failure rates, I'm going to take a broader approach and step aside and think about why this really matters. I see a few new people on today, so welcome to the webinars. We're glad that you found us. We're really happy that you're learning more information about functional safety. For those of you that don't know me, my name is Lauren Stewart. I'm a CFSE here at Exida. I work mostly with our mechanical customers, so a lot of the times when I'm talking in my webinars, I refer to valves and actuators and the final elements because of that mechanical background. I help our customers achieve certification to the IEC standards and help them fill any of those gaps that they might need. I also help teach with Exida Academy, some of our training courses and these webinars as well. If you are unfamiliar with Exida itself, we are involved with everything you can think of dealing in functional safety. So if it's process safety, functional safety, even alarm management and cybersecurity, whether you're the OEM who's building parts that need to be used in safety systems, the whole way through to the end users using those certified parts to build those safety systems to protect against risk. We have tools, we have services, we have certifications, we have trainings, we have people that can help make your job easier, help get you up to speed, help train you, anything you need dealing with functional safety and reliability. I like to say, no matter where you are, your customers are, or where your products are coming from, we have somebody close by that can help. So if you are needing help in functional safety, alarm management, or cybersecurity, we have somebody that can train you, somebody that can get you tools, someone that can help with consulting, someone that can help with certification close by. And something I'm really proud of working here at Exida, I like to say Exida is, sorry for the pun, but an open book. Everything that we're researching, all of our processes, our procedures, everything that, all of our data collection, our studies that we're doing, we print it. We make sure that everybody has access to that. We feel that if we are learning things to make the world a safer place, we need to get that information out there. So whether it's in these webinars that we are doing or our blogs, whether it's in the white papers, we go to conferences, we publish books and databases, we get that information out there for everybody to see. Even if it's our customers or even if it's our competitors, everybody in the public can see everything that we do. Because we really do think if we work together, we can make the world safer. But let's get back to today's webinar. Throughout today's webinar, if you have any questions, please feel free to write them in the questions panel of the webinar tab. Throughout the webinar, I will try and pause, see if we have any questions and answer them. However, I'm not the best at that. I usually get started and I get on a roll, I get talking, and I don't stop until the end. But at the end of the webinar, I will take some time and answer any questions that you have, so make sure to write them in the questions tab there. If you have registered for this webinar, you will get a copy of the slides sent to you either later this week or early next week. And this webinar will be recorded for our YouTube station and our website. So if you want to reference back to it later, feel free to. You can just look on our website for a link to that. Let's go ahead and get started. As I told you before, I wanted to do that zoomed out approach on what functional safety is, the bigger picture on why functional safety is actually important. I want to talk about what it is in real life, not what we calculate or what's on pen and paper or what our software said was important. I want to talk about real implications of these calculations in these notes. At the end of the day, the main goal of IEC 61508, IEC 61511, all of the functional safety standards of product certification, of failure rates, of fits, of basic general functional safety is to prevent serious and potentially deadly catastrophes. So when we are going through this webinar, keep that in mind. Those potential deadly accidents are why functional safety is really so important. When we are asked about what functional safety is, normally the first definition that is drilled into our heads at the very beginning of what is functional safety, you hear of risk. It's all about risk. Personnel risk, environmental risk, financial risk, and reducing that risk. But that's all well and good, but what does that really mean? At the end of the day, the main goal of everything is to prevent those big accidents, those potentially huge catastrophes, those deadly incidents. When we talk about safety system and functional safety, those safety systems, your SIFs and your SIS, they're put in place to avoid that potential disaster when everything else doesn't work. Your SIF is usually your last line of defense. So you want to make sure that that last line of defense is actually what you calculated it to be and actually going to work when you need it to. Unfortunately, we are all familiar with different current events that highlight the need for better safety systems, highlight the need for their care and their maintenance. And even with all of the knowledge that we have, with the great standards that we have, the wonderful products that are out there, there's still accidents happening. So obviously there needs to be more. There's no reason at all that in this day and age with all of our technology that there are accidents that still involve injury and death. Some of the more recent accidents have actually calmed down and exposed that there is still a lack of functional safety and process safety management. There is poor safety culture. There's a lack of mechanical integrity of products. There's poor maintenance. There's poor operations. There's poor training. And unfortunately, many times, functional safety doesn't get addressed or even thought about until after some accident occurs. Or in many cases, maybe a potential disaster or maybe a near miss, or sometimes we get called when somebody's competitor has an accident or a near miss and they realize that they're in the same boat. I'm sure that most of you, if not all of you, have heard of the Texas City accident that happened in 2005. This occurred when a major explosion happened. A hydrocarbon vapor cloud, it ignited and it violently rocked their ISOM process unit. It killed 15 workers. It injured more than 180 other workers, and it severely damaged the refinery. Of course, going back, there have been a ton of studies, a bunch of research on what went wrong and what happened. And at the end of the day, almost everything that you could think of to go wrong did go wrong. There was little to no safety culture at this time at this facility. Devices were broken and either marked that they were fixed or marked don't worry about fixing it. Tests were ran like proof tests. Oh yeah, we ran that proof test when they really weren't. Systems were bypassed. People were in areas where they were not supposed to be during startup. Alarms were ignored. There were alarm flooding going on. People ignored safety protocol or did not know safety protocol, which is ignorance is no excuse, just as bad. There was a new operator working and a fatigued operator working. There was no management on site. All of these individual problems could have easily been avoided by just one or two small, simple things. However, it wasn't. And in this case, they all added up to a catastrophe, an absolute disaster. In the Texas City case, there were safety systems in place. However, they weren't taken care of. There were things broken and not fixed. There was maintenance supposed to be done that was not done. There were parts in that should not have been in. And this was just a complete disregard for safety culture, was in effect for several years, just adding up. There was actually an internal report done and released just 3 months before this major explosion happened. And it actually talked about the lack of maintenance and the whole, well, we don't care attitude at this refinery. The report's co-author put in the report, we have never seen a site where there was a notion I could die today was so real. People were actually afraid to go to work. And that's a very, very sad thing. No one should be afraid to go to work. Even after the major accident where 15 people lost their lives and 180 people were injured, they still had issues in their safety culture. There were still accidents straight from poor functional safety at this site. Just months later, a hydrogen gas heat exchanger pipe ruptured, causing a large fireball, and somebody was seriously hurt from that. That happened because maintenance came, changed out parts, didn't really follow procedures, didn't care, and the parts were not okay to go in that type of severe environment. And then a few months after that, there was another explosion that resulted in the entire community ordered to shelter. And this occurred when there was a hole that developed in the bottom of a valve, and the high pressure blew the valve off, and a worker died from that severe burns. Another current event, well, semi-current, it's 2005 once again, is a major storage facility in Bunce Field, UK. There, it happened. It was a large multi-tank explosion, which thankfully happened at 6 a.m. on a Sunday morning. If it did not happen at that time and the facility would have been full of workers, the result would not have been only 40 people injured. The result would have been much worse if the explosion happened in operation hours. Fuel overspilled into a bund, it vaporized, it found some ignition source and exploded. One tank exploded to another, causing multiple tanks to erupt, and it took over 4 days to put out that fire. When once again, research and the report was written on to see what happened, right in that report, the investigation board said that there needs to be safety measures in place to prevent fuel escaping the tanks when it's stored, excuse me. There needs to be added safety measures when fuel does escape so it does not find some ignition source or potentially poisoning the environment. And then we have a more recent one. This is actually the Husky Refinery explosion that happened in northwestern Wisconsin in 2018. And this explosion happened when a tank of crude oil exploded. 36 people were injured. Thousands were evacuated from their local homes and businesses. This massive, huge explosion happened when a worn valve it was worn down too much. It allowed air to leak and mix and combust. Fortunately, as I said, unfortunately, 36 people were injured, but the good news was this explosion happened when the unit was on a break. So most of the people were away from the direct blast zone, and that injured number and the possible death number would have been much greater if that did not happen during their break. The refinery isn't expected to open for at least 18 months after the explosion, and the fire and the explosion resulted in $27 million in damages and another $53 million in other costs related to the accident. And there's more. That's not all. Those are some big ones, but even more happens. These are some industrial accidents, and these are just in the United States alone. All of these accidents could have easily been avoided if they would have worked with a safety system and a decent safety culture. So putting SIFs in place, using the good products with good calculations, having good operation and maintenance and safety culture could have avoided all of these. In these cases, in most of these, the primary focus goes directly to the injuries and the death numbers. Being humans, that's going to be what we emotionally get drawn to. But there's even bigger picture than that. In all of these, there is an impact on the environment. There's a cost to clean up. There's going to be fines and penalties. There's property damage. There's loss of production. There's hurt business reputation. And there's even trials being either civil or criminal or both. And as I said, there are times where even jail terms get handed out along with the penalties, the fines, the cleanups. As safety systems and SIFs are becoming more and more complex, the importance of functional safety increases dramatically. So as things are getting smarter, we need to get smarter as well. We need to consider things like machinery and robotics and cyber, along with the regular functional safety world. In this example, this happened in a machinery plant where a robot went out of its section when it was not supposed to, went into another section. Once again, it was not supposed to be in that area during a time when a woman was maintaining another machine. Unfortunately, it mistook her as another robot and crushed her. It resulted in her death. Once again, the investigation showed, well, not only this should have never happened, well, the robot shouldn't have been there in the first place. There was a failure in one or more than one of the safety systems. The robot shouldn't have left its original place. It shouldn't have mistaken her. It should have gone into this roped off zone. So if the automated safety systems that were in place would have worked properly, this could have easily been avoided. And unfortunately today, especially if you live in the United States or the land of litigation, it is super important to be focused on functional safety. More often than not, if an accident happens, it will go to trial, whether it's civil, criminal, or both. And it's not enough anymore just to go over and make sure the big company is paying. There are now civil cases where managers and even down to engineers were held liable for their actions. So what does this mean for you? Each role is going to have your own responsibility. So what do you do? What's your responsibility? What's your role? And what does functional safety have to do with you? And make sure that you're going to be competent and doing everything you need to do to make that role in functional safety happen. Say you're a design engineer or an OEM. You need to make sure that you have a reasonable level of expertise in what you're doing. You have judgment, you know of the application, or you know of the details. When you make your product, you also get that functional safety specifications out to your customer. Your failure rates, your safety manual, all of that. Make sure you're supplying the appropriate information. If you're someone like an end user, make sure that you are asking the right questions, getting the right information from the design engineer. Make sure that you are maintaining it, proof testing it, pulling it out when useful life. So depending on your role and your responsibility, depends on what you need to be responsible for. A study in actual real life industrial accident causes done by the health and safety executive in the UK showed why real things happened. And as you can see, one of the biggest chunks at 44% came down to the very beginning, specifications between functional requirement and safety requirement specifications. So as you can see, 44% of accidents came from before a device was even put into place. If we follow that pie chart around, you can see 15% in design and implementation. There were errors in installation and commissioning, in operation and maintenance, and modifications or changes after commissioning. So as you can see, no matter if you are where you are, what your roles are, there's room to grow and room to improve. If you are an OEM, that 44% you have control over. You can get your customers the correct information and make sure they have as much as they can. If you are an end user, make sure that you're doing your operation and maintenance correctly and on time. And if you make a modification, go back through the safety life cycle, see what possible unintended errors that could be introduced. When this comes down to what your responsibilities are, once again, it comes down to who you are, what your job is. First of all, know your role and your responsibility and what it has to do with functional safety. You would not believe the amount of time we have gone into a customer and said, well, what is your job with functional safety, or what is your responsibility? And it's not an easy thing all of the time to pin down. So the first thing we always suggest is to know your role and responsibility. If you are a manager, make sure everyone underneath you is aware of their roles and responsibilities and that they are well defined. With that, the number one thing, no matter who you are or what your job is, you need to be competent. And that's a big one. The new standards, the new version of both IEC 61508 and 511 have really turned up the language and competency. It's not anymore just, well, do you know how to do your job? It's no, let's prove it and continuously update it, continuously prove it. So make sure that you are competent to do whatever role you are supposed to be doing. If there are any gaps, that's okay. Set up a training program to get you caught up to make sure that you don't have any gaps. Back in the day, way back in the day, if you got called to trial, you might have been able to say, oh, I'm sorry, I didn't know. That doesn't cut it anymore. Ignorance is no longer an excuse. And if you do get called to trial, they will say, well, there were these standards for functional safety. Why were you not competent in them? And then for your responsibility, I always say imagine the bigger picture. Take a step back. If you're designing a product, think of the people that product that will be protecting. I always say, if I'm doing calculations, I always say I do the calculations as if someone I love is going to be in that plant, because you never know if somebody is. I sleep really well at night because of that. I always say, remember, go back to why there was a need for this SIF in the first place. This valve, this actuator is going into place because originally there was too much risk involved in normal operation just to open up the door. So whether it's just too dangerous. So on top of the design, on top of the BPCS, any alarms, any other safeguards on place, it was still too risky to open up. It was still too risky to start up. That's where your SIF comes into place. That's where what your valve is going to be protecting against. So this could be an extremely toxic substance like an ammonia plant in the middle of a cornfield, or this could be a power plant in the middle of a city next to an elementary school. That's what risk you're taking out. That's what you're protecting against. When the end users are doing the calculations, a lot of the times they're coming down to calculating what is the probability of failure. What is that chance of failing within a time period? The standard says you can do this a couple of different ways. You can simplify things and only look at failure rates and your proof test intervals or that time interval. Or you can be specific and not make assumptions and look at everything from failure rates to mission time, proof test interval, proof test effectiveness, the time for restoration, proof test duration, any redundancy, common cause, operation and maintenance, and probability of initial failure. That's a lot to consider in just one equation. And if you think about these, different people control these different variables. So something like the failure rates of a product or any diagnostic coverage from a product, that's going to come directly from the OEM. That's going to come from an FMEDA report or the back of a certificate. Those are the failure rates for a device. But a lot of things like the mission time, the proof test effectiveness and interval, proof test duration, those things can be they can be guided by the OEM. They can say, we suggest you proof test this often, or we suggest this is the proof test that you should do. But it's really up to the end user if they're going to follow those suggestions, when they're going to proof test, what the effectiveness is, how long it gets them back up to restoring their system when something is down, how well their operation and maintenance is going to be. And some of these things, it's going to be a combination between the two, depending on the different variable. Depends on who controls it. So think to your role and your responsibility. Are you the OEM? Are you the end user? You cannot control everything in the PFD average calculation, but do your best to control what you can. If you are the end user, how is your operation and maintenance? Are you testing on time? That type of thing. Where the spotlight usually shines down on, and where many consider to be one of the more important parts of SIF design, comes down to your final elements and final element issues. There was a study of over 80,000 SIF designs done, and final elements contributed the majority of the PFD average, or that probability of failure, probability of that dangerous failure happening. When we look at SIFs, we normally see the valve, the solenoid, the actuator, those final elements taking up over half of the probability of failure, usually within the 70% range. So if you are an OEM and you deal with final elements, or if you're an end user, keep your final elements in mind. This is an area that you may be able to really improve on. This is an area that is usually considered the highest probability of failing, and if you improve the safety of it, and I'm not talking about just improving it on paper or just improving the failure rates or just improving the calculations like we all want to see. I'm talking about actually improving the safety, like in the real world. That impact will really be felt if you can take those final elements and improve the safety. You can really improve the safety of your SIF. And we know that human factors will always play some part of safety performance, some part of negative impact on safety performance. And we know that there's always going to be accidents as long as there's going to be humans involved. There's always going to have some sort of injuries. But if we apply functional safety, apply it correctly, and think of that zoomed out picture of why what you're doing is so important in your everyday life, we may be able to just improve functional safety a little bit. whether it's in a more reliable product, getting the information to your customers, or your customers having a more dependable safety culture. The manufacturing world and the process safety world can really be a safer place. I am going to go ahead and take some questions now. Of course, I didn't save time throughout it. I'm sorry about that. And if you think of questions later on, please feel free to email me, and I will get to them as soon as I can. There might be a little delay, but we'll get to them. And if this was something that you really enjoyed and really loved information on, we have more. If you want to dive into functional safety, you want to improve your competency, we have trainings for that. We have trainings on functional safety, alarm management, cybersecurity, different locations, and even online now courses. And if you think of things later, please feel free to reach out to us. I don't have any questions this afternoon, so I'd like to say thank you so much for joining us, and we hope to see you at another exida webinar. Thank you.